Good afternoon, everyone. Welcome to this week's episode of The M Word. I'm Robin. I'm the Technical Director here at Man & Machine in the UK. And as always, it's a pleasure to be with you this afternoon. It's been a little while since we've done one of these actually, so I'm going to pre-apologise for any mistakes I make pressing the buttons in the recording studio here. We've had a few months off. We've been doing a lot of renovations, as you know, here at Man & Machine Towers. And finally it's all finished, so I think in a couple of weeks time we'll give you a little tour on one of these sessions just so you can see all of the new fancy rooms and tech that we've got here in Tame, should you be interested in seeing so. But welcome to this session. A little bit different today. We've got people watching us on both our private Zoom and YouTube Live as well, so good afternoon to those of you on Zoom and good afternoon to those of you on YouTube Live. And today we're going to be focusing on a very specific subject. Usually these sessions air, I say usually, they haven't for the past few weeks, but usually these episodes air 2 o'clock every Thursday afternoon, and we just spend the opportunity to spend some time looking at something in the Autodesk design space, sharing a cup of coffee, cup of tea, and just looking at a tip, a trick, a what's new, or a specific workflow. Today we're going to look quite specifically at a transitional workflow. If any of you out there are using a different CAD system or design system that is not Autodesk, whether it's SolidWorks, whether it's CATIA, whether it's Pro Engineer or Creo, whatever it might be, if you're looking at transitioning over to the Autodesk world, we're going to look at some of the different workflows and then some of the benefits that we have within things like the product design and manufacturing collection from Autodesk. So usually we're about half an hour or so. Today I think we might take a little bit longer than that, so perhaps 40-45 minutes, but we'll see how we do for time. But as always, thank you for taking the time out to come and join us. Your time's obviously precious, but hopefully you find the workflow that we are going to go through useful. So what we're going to do is just shrink me down. Let's go into the corner and let's share our screen like so. So when it comes to transitioning across to Autodesk, there are a number of questions that we come up with week by week, or well, we don't come up with them, but our prospects and clients come up with a number of different questions to understand how they can use legacy data. What happens if they want to bring in a file from SolidWorks and edit it? What can we then do realistically with that file once it sits within Fusion 360 or once it sits... I'm looking at that camera, but I've changed you to this one. I told you I would get messed up with the buttons, so rather than talking to my ear, I'm going to face the camera and talk to you. Thank you, Ellie. So I've completely lost my trail of thought. Where was I? At least you can tell it's live. So yeah, what can you do with those files once they're inside of the Autodesk ecosystem? And that's what we're going to be focusing on today. If we take an example, so let's imagine that you're using a SolidWorks CAD system. You're working with solid parts and solid assemblies. What can we do with those if we want to bring them into the Autodesk ecosystem? And once they're in that ecosystem, what can we then do with them? How can we work with those inside of Inventor or Fusion 360 or 3ds Max or whatever else it might be? And we're just going to spend the next 35-40 minutes or however long looking at some of those examples and trying to see and appreciate how they can work for us. I'm conscious that I can see in my preview window a load of graphics glitches, so I'm hoping they're not coming through your end. But we're actually going to start life inside Inventor. I'm using Inventor Professional and I'm on the 2024 version. But although I'm running the latest and greatest version of Inventor, this workflow is actually possible in a number of previous different releases as well. So if you're running Inventor 2023, or if you're running Inventor 2022, or even 2021, a lot of what I'm about to show is possible and usable inside of those systems as well. So what we're going to do is open up a SolidWorks file directly inside of Inventor. Inventor can bring in both native and third-party external facing files. So some people out there might be using a STEP or an IGES file as an output from something like SolidWorks. We can handle those exactly the same inside of Inventor, but we can also handle the raw SolidWorks data. This is where versions are quite important, so it does get quite specific with regards to which actual version of Inventor you have. For instance, Inventor 2024 will open the corresponding SolidWorks version file. Inventor 2023 will open the corresponding SolidWorks version file. So it kind of go year on year. So you can't expect to be in an older version of Inventor but be able to open a newer version of a SolidWorks file. It's just the way that the two organizations share their file formats and the ability to work with them year on year. So what I'm going to do inside of Inventor, I'm going to go through two workflows. So first and foremost, I'm going to show you bringing in an assembly and then starting to make some modifications to that part. Then we're going to strip that back and we're going to look at an individual part that's sheet metal, maybe that's come across from SolidWorks into Inventor. Just a nice simple bracket. And with that bracket, we're going to show you that we can actually turn that into a sheet metal component into Inventor so that it will flatten it and everything else that goes with it. So hopefully a nice, useful workflow. Thank you for the feedback on YouTube. It looks like the glitches are coming through, which is a little bit concerning. I know why it's doing it, but I don't know if I can stop it without affecting the stream. So bear with me and I'll see if I can tweak that as we go through. So on my machine here, I've just got some sample files that I've downloaded directly from the web for SolidWorks, so they're in the latest version. And on here, I've basically got a filter at the bottom. So when we're opening files into Inventor, by default, it filters to IAM, Inventor Assembly, IPT, Inventor Part, so on and so forth. So I'm going to come down and change either to all files or just focus very specifically on SolidWorks files. And on those SolidWorks files, you can see that I can instantly see all of the parts and assemblies that make up this simple joint and crank. I'm going to select this solid assembly and press open. And while that's opening in the background, I'm just going to try a couple of things on my broadcast here to see if I can get it to stop the glitching. So give me a second. Hopefully I don't drop whilst it's doing this. I hope that I don't. With a bit of luck, we can change to a slightly different encoding setting, which should give us a little bit better of a workflow. Okay. Zoom and YouTube Live. Give me a second. So give me one moment. There we go, should be back. Glitches still appear to be there. Just making sure the audio is coming through okay. No audio, that's okay. So we should be back now. It looks like the glitches are still there for some reason. So just give me a few seconds. I'm just going to try and figure something out. Yeah, I think we've got a few issues with our Zoom. Okay, try that now. Have we got any audio? I'm just looking around to my helper here. No, okay. So I think YouTube's okay. So I'm literally just going to dip out of the Zoom and drop back again just to fix this little glitch that we've got going on. So give me 2 seconds. I will pass control over to my colleague temporarily. Those of you watching on YouTube, apologies. Just give me 2 seconds and we'll be back with you. Ellie, you've got control over the room for a second. And then we're just going to stop and start our virtual camera and restart Zoom. Apologies about this. Wasn't expecting this to happen. First one back for a little while, but hey ho, we should be okay. Ellie, can you make me host again, please, on the Zoom? I've got it. Hopefully you can hear me again on the Zoom platform. People saying yes, people saying no. Having a few issues, which is frustrating. If those of you that are watching on Zoom would like to move over to our YouTube channel, everything's streaming okay on there. I'm going to try one more time to fix the Zoom, but we might just have to switch to running purely on YouTube Live because things are causing a few issues. So again, please bear with. I'm just going to pause the stream on YouTube. Okay, there we go. I'm back. Can you hear me on Zoom? No. Okay. Those of you on Zoom, I'm going to, rather than keep trying, I'm going to stick the YouTube live link in the chat. So please feel free to join us on there. But I'm going to stop the Zoom broadcast because clearly it's not working. Apologies for that. Okay, so let me just leave the Zoom as it's causing a few problems. And we'll just carry on YouTube. Okay, the joys of technology. Where were we? Let's share the screen again. If someone can just give me a little nod or a thumbs up or something on YouTube Live just to make sure that the audio is coming through. It should be by the looks on my screen. Everything looks okay. And let's share my screen. Good, we're back. So we've imported this SolidWorks assembly, this SLD ASM file. And what that assembly is going to do is it's going to give us two options. So when we're working with external data inside of Inventor, we can use that file as a reference. Think of it a bit like an XREF from a CAD perspective. It will link to that file and keep a live reference to that particular component, which is really actually quite useful. So aside from potentially transitioning over to an Autodesk ecosystem, if you're collaborating with someone outside of the Autodesk interface, we've got the ability to create a live reference to their files. So if I want to, I can link to a SolidWorks file or a CATIA file or a step file or an IGES file, and I can keep a live reference there. So if that file updates, my part or my assembly or my design and Inventor will update as well. And Autodesk have gone a long way over the past few years to really get that reference geometry working well. We're going to convert the model. And when we choose to convert the model, we've got a number of different options. Because it's a separate CAD system, we need to identify what we would and what we wouldn't like to import. So for the purpose of this, solids, surfaces, meshes, wires and work features, I'm just going to leave it as a default for now. I'm more than happy with that. We want to define that we're going to be coming in maybe in millimeters rather than using what's in these files, which I happen to know is inches. And then we can choose different assembly structures, different options for bringing in composites or surfaces, as well as suffixing or prefixing the name of the individual files themselves. From there, I've also got a selection option at the top. The selection option will allow me to load the model in preview mode and physically go through and do a selective import. That's really useful for vast or complicated files. This allows you to go through and be a little bit more selective with those imports as you come in and limit what Inventor's doing. Finally, we can also do a property map, which again is really very useful if you've got a step file or a SolidWorks file that contains properties that you want to map over. You can see that Inventor has identified that it's a SolidWorks piece of data, and therefore it's going to bring across the mappings for the title in SolidWorks becomes the title in Inventor. The comments in SolidWorks becomes the comments in Inventor. The part no in SolidWorks becomes the part number in Inventor. But you can customize that and tweak that as you see fit. So the likelihood is you're going to have some custom properties inside of SolidWorks. We call them custom I properties in Inventor. And we can make those mappings and change those mappings as you see fit. I'm going to go ahead and press OK. And once that's done, what essentially we're going to end up with is that SolidWorks data natively inside of Inventor now. So we have the parts, the sub-assemblies. So I've got a sub-assembly here and a sub-assembly down here. Sorry, no, these are individual parts. And I've also got some work axes here as well. So it's brought across the work geometry from SolidWorks. Now it's important to note a couple of things. These components are imported components. They are not modeled natively from the ground up inside of Inventor. So when you bring across a piece of data from any external CAD system into another, whether it's SolidWorks to Inventor, Fusion 360 to Creo, or whatever it might be, when you do that jump, you will lose the history of that part. There's no way to properly pull it in. We can get a plugin through the App Store to the top right of your Inventor screen called feature recognition. What feature recognition will do is it will go through a part and it will do its best to figure out what are the build-ups, what are the features that have been used inside of this component. Where's the extrusions, where's the revolves, and where's the sketches. If you've got a simple box, you know, a 500 by 500 cube, the feature recognition will look at that and go, oh hey, you've got a 500 by 500 square sketched and you've extruded that by 500 mil. Brilliant, and that works fantastically well. But in examples that are, you know, real life, it doesn't know quite exactly how the designer put it together. So it only gives you like a best hit. It does its best at finding what it thinks you've done and then it recreates it. But it's not perfect. There are better ways, easier ways, and more powerful ways to edit existing geometry when you're importing these files, which is what I'm going to show now. But if you look at what you have, you know, if I look over on the left, I can see that I've got a third-party import log, and everything that's been imported, if I give this a double click, will save in a little HTML file, and it will show me what's imported and how it's imported and if it's come across any errors. One thing that it does struggle with sometimes is things like self-intersection. You will be unbelievably surprised at how non-Autodesk CAD systems will allow self-intersection. And when you bring a model with self-intersection into Inventor, it will turn it into a composite because it will say, well, you can't be a solid because you're self-intersecting, and it will make you repair the geometry. So in cases like that, you'll get a surface model rather than a solid, and it will show you that inside of that import log. But what we have here is a load of components. So if I open this yoke here and have a look at what we have, it's a real nice 3D model. It looks great. All the details there, we've got all of the information on our screen. But if we look on the left-hand side, it's just a lump. It's just a solid lump. We've just got a single solid body. So we don't have sketches or extrusions or sweeps or lofts or revolves or anything like that. That's the same for all of these components, no matter how complex or how simple. You just won't get that feature recognition, but that's not an Autodesk thing, that's just a generic moving from one system to another. But what if you want to make tweaks? What if you want to make parametric, intelligent edits to your designs? Actually, it's very straightforward using our AnyCAD and Direct Edit functionality in Inventor. The first thing you may be noticing as you come into Inventor, by the way, if you are a user of another CAD system, is it's quite familiar. Yes, the buttons look a little bit different, and maybe they've got different icons, and maybe they're called assemble rather than mate, or joint or constraint rather than mate. But actually the process is kind of the same. Punch for punch, all of these applications are very, very similar now. They just look slightly different. So what I'm going to do is I'm going to drill down to this component. So I'm going to right click and open this sub-assembly to show you that it is an assembly in its own right. And I'm going to right click and open this individual component here. So in here we've got a number of different things. We've got a hole, we've obviously got a revolve that's been made at some point, maybe a shell at the bottom here, certainly a couple of fillets and some information at the top. What I'm going to do is make some edits. Now first and foremost, should I want to, I can just start modifying this using Inventor functionality from scratch. For example, let's say that we want to put a bit more detail around the spherical face on this component here. I can place a work plane tangent to that surface, but parallel to this plane, and I can sketch on it. Just like you would if this was a native raw Inventor file. So let's come in and maybe we're going to put a simple slot in here, like so. I'm not too fussed about the sizes for the purpose of today. Where's it gone? There we go. And I'm going to extrude it as a cut into the component, like so. So we can make generic edits as if it was a Inventor model or an Inventor model. But what if we want to edit this fillet or this hole or the extrusion here? How might we go about doing that? Well, actually pretty easily. We use direct edit. So on our ribbon at the top, we're modifying the components. So we go to the modify tab. This ribbon's fantastic across the Autodesk tools. Top to bottom, left to right, natural workflow, just like reading a book or reading your payslip on payday. We can come in and use direct edit, and I can choose to directly edit these components. So let's grab this, this face here and say that actually we want this face to be a bit longer. So I can grab that extrusion part and just pull it down. You'll notice that when I pull it down, whilst I'm doing this by eye, I've also got a type-in value. So I can be very specific about the distance we have changed it. Not the overall distance. Remember, Inventor doesn't know how that component's been modeled to begin with. We haven't got any features on there. So it's just based on 0 being where it is now, a positive change or a negative change. Because it's typing in a value, that will create a parametric constraint. And this is really the key here. We're making an intelligent parametric change, meaning we can change it again and again and again using a single parameter. Let's give you an example of this now. I'm going to give this a name. So I'm going to say this is a face change. My keyboard decides to work. There we go. Let's call this face change equals -2. Press enter. That instantly makes that change. I'm going to change some other bits in here on the fly. So let's select this face and drag it upwards. Oops. Try that again. Direct edit, this face and this face. Make sure you don't click an extra one. So I'm just going to drag that upwards to make it a little bit bigger. I'm going to select this one and drag it upwards to make more of a point on the component. And we're going to grab our size tool. And we're going to resize the chamfer that we've got on the top here. I'm going to come to this hole at the bottom, grab the hole and make it bigger. I'm going to grab the depth of the hole, make it shallower. Screen is a little bit jerky, which I'm going to apologize for, but I'm going to go with it. Make that a little bit shallower there. And then maybe grab one of these fillets. That's more of a complex T-spline modeling procedure. I'm going to grab this large fillet and I'm going to edit it and I'm going to make it different. So I'm just going to make it a little bit smaller here, like so. Obviously there are constraints that you're working within here. You know, you've got to look at how you're modeling it. It won't let you do something that you can't do for obvious reasons. But we can come in and make changes on the fly. I've just been sizing these for now, but we can also move. So if I grab this component and go to move, I can move it up to make a point or down to make, you know, a flat and get rid of that face altogether. So let's make more of a point. We can scale things up and down. We can even rotate. So I could grab this and start rotating this face around as we see fit to create a draft on there, should I want to. As I say, all of these changes that you make, whether they are Autodesk Inventor, direct modeling, or let's say original modeling with sketches and features, whether it's a pick and place feature like a thread. Let's put a big old thread on that one there. Or whether it's one of these direct edits, everything is saved. So here's my import, and then I've got my extrusion that I made back to the original sketch. Just like in SolidWorks, you've got the sketch there. We can go in and we can tweak that. It's the same as you would work inside of SolidWorks. We then have our direct edits. And that direct edit, I did all of that in one hit. But if I pressed apply after each one, I would get a separate tree in the model browser with all of those direct edits on. And all of them are parametric, they're intelligent. It retains the information. If I go back to my parameters at the top of the screen, you can see that for a file that we've imported, we've got a remarkable number of parametric parameters in here, or dimensions. Remember the face change we did a moment ago? It's still in there at -2 millimeters. Let's change that to -1 millimeter. Let's change it to +3 millimeters. The parametrics are there. It understands what we've done and how we've done it at all ends of the spectrum. So we've got a tool that is actually really, really powerful. We're taking in third-party CAD data from any CAD system that we support. It's not just SolidWorks, any CAD system, and we're directly editing it on the fly to make realistic edits that we may want to do in the reality. Once we have that inside of Inventor, we can work with it, we can control it, we can create drawings of it, and so on and so forth. It's now Inventor geometry that we can work with and control. So first and foremost, that's really powerful, using direct edit to be able to manipulate and work on the functionality. What else can we do? Okay, well, let's strip this back. Let's go and open up an individual SolidWorks part this time. And we're going to go and open up just the bracket, the same bracket you just saw, but we're going to bring in that bracket on its own. This is a piece of folded metal, and I want to make it a piece of folded metal in Inventor so that Inventor can flat pattern it, create a DXF if it needs to, or go and do a laser cut using our CAM functionality that comes out of the box with the Product Design Manufacturing Collection for the same price. You don't have to buy Inventor and this bolt-on and this add-on and this functionality. For one subscription, you get all of the CAD tools and all the design tools that you need, including automation using iLogic inside of Inventor. Think DriveWorks, but it's in the box. You get all the visualization inside of 3ds Max, which is a world-leading media and entertainment piece of software. It's used in high-end video game, TV, and movies to create photorealistic renders. It all comes out of the box. So inside of this part now, I can convert to sheet metal. I'm going to go into my sheet metal defaults and tell it how thick this component is. And from this, I'm just going to do it on the fly. So rather than having, oh, it's come in inches, that's frustrating. Rather than, let's do it again. My brain can't cope with that. We want to work in millimeters, please. Let's open that up. Choose open. And let's convert it to millimeter. Thank you very much. And on here, let's go in and convert to sheet metal. Let's just make sure that it might be my templates actually more than the model. So let's make sure, yeah, millimeters, great. Let's come in and change my defaults. And in my defaults here, I'm just going to measure from there to there. So grab the thickness of the component. It's quite thick. At just over 6 mil, but put the thickness on there. We can then use those sheet metal defaults to further define. So if I wanted to define my bend radiuses or my unfold rule or a bend table or relief shapes or corner seams or anything like that, I can. I'm going to leave this default. I've just changed the thickness. And I'm just going to say, go ahead and make flat pattern. And Inventor will then use that thickness, look at the design, look at where the radius is, and it will unfold that part. Simple as that. We now have an unfolded component inside of Inventor. Whilst it's unfolded, I'm just going to place a slot on there. So let's go ahead and say when it's unfolded, oops, wrong type of slot. Oh, I'm in the flat pattern, aren't I? Go to folded model, actually use the unfold tool rather than that. All bends, there we go. Apply OK. Let's place a sketch on the top here, and let's just do a circle. Eyeball that over one of the bends. Let's cut that through all the way through the material, and then let's refold using the same stationary reference, or the bends. Go. And there's our cut over the bend. So we can turn it into a sheet metal component. We can unfold it. We can now get our sheet metal blanks. We can do our CAM toolpath if we want to, so on and so forth. I'm just going to put a quick save on here. And then with this, I'm going to say that I want to use a Fusion 360 workflow, which is a workflow that comes in Inventor, especially when you buy it with a product design and manufacturing collection, which contains several products. And I'm going to say that I just want to send this component over into Fusion and do some things in it. I can do simulation, FEA inside of Inventor. I can download Nastran as part of the collection and do some both linear and non-linear simulation, as well as other things. But I'm just going to send it across into Fusion and just say, I'm going to do some stuff inside of Fusion. What it will do is it's going to connect up to my, my Fusion team location. I'm just going to put it into a team that I can find. Let's put it into this manufacturing team here. And let's go ahead and choose a project. Rob's project will do. I've got no idea what's in there, but let's go in there and let's call it bracket demo and press upload. This is going to basically take the data, save it, upload it to Fusion 360, put it in the right project, and it's now opening Fusion 360 on my desktop and allowing me to use Fusion to do some bits and pieces. Fusion is a fantastically modern and very easily accessible tool. If you wanted to, you could realistically use Fusion alongside any other design package. So Fusion's CAM tools, Fusion's simulation tools, and actually Fusion's visualization tools are very, very powerful given the price of the product. You can bring native SolidWorks data, native other CAD data directly inside of Fusion and do what I'm about to show you natively. I'm just showing you through Inventor because typically I would, that's what I'm here to do. The joys of live updates, yay! This isn't going well today. So Fusion's decided it's going to do an update, so it's not going to import that design. I'm going to say you are going to import that design and make it do it anyway. So let's come in and find my project. There's my bracket. Let me upload it and open it. That's frustrating. Okay. Has that done it? Did you do it? No. Okay. That's a shame. I was going to bring it in and just show you some of the visualization tools and do a quick simulation in here. I'm not going to run an update whilst we're doing a live session. So we'll just quickly do it in Inventor. But you could send this out to Fusion to do it inside of Fusion 360. In the purpose of this, again using my, my good old Inventor Professional, I'm going to come into Environments, Start Stress Analysis, which is not an additional subscription with Inventor. We're going to say that we have this bracket is bolted to the desk on the underside, and I'm just going to put a bit of weight on it for the purpose of this. So let's do a single static. Let's create a material. We're just going to use an override material of aluminium. Hit OK. We're going to have a fixed constraint on the bottom here. I'm just going to put a simple force on this radius at the top and on this face here. And I'm just going to say, for the purpose of this, we've got 25 on there. Nothing too big. We've got a bit of gravity as well going in that direction. Mesh the component. I could refine the mesh if I needed to. So if I wanted to have more refinement on my mesh around the fillets here to get a more realistic result, I could. I'm just going to go ahead and hit simulate. It's quite a thin part, so I might have needed to use thin bodies, but again, out of the box in Inventor, without using any additional add-ins, we can come in and do a quick simulation. I was going to show you that inside of Fusion, but I can't because it needed an update. So that's my mistake more than anything else. But we can now see our underformed result. We can go and look at our safety factor of material. So we are well within limits, minimum being 6.6 safety factor. If I want to see exactly how it's moving, I can do an adjusted view versus my original part to see how it's moving. Should I want to put some stiffeners in there or a bit of thicker material or whatever it might be, I could do that. But again, to do this functionality with a non-native part and get realistic results is very, very powerful indeed. Finally, should we want to, we can get this across into a rendering environment. So if I come across and open 3ds Max, I'm conscious on time, so I'm just going to do this fairly quickly. But again, we've got so many tools inside the Product Design Manufacturing collection which allow you to do more than just design. And they're all in the box, so to speak, the physical, virtual, non-physical box, for one subscription per year. And it gives you access to everything from AutoCAD to Inventor, Fusion 360, Navisworks, Recap. There's so much in there, I can't remember all the different tools. Vault Basic is probably the most interesting one because on top of all of this, you want to manage that data. You want to have version control and check in and check out your data to protect it and make sure that no one's editing the same thing in two separate locations at two different times and things like that. So we're not going to show you Vault here today, we're just focusing on the design tools, but should you want to, we've got that functionality in there and it works really nicely. So just to finish this off, let's take our non-native Inventor component and let's bring it into, where's it saved it? There it is. Let's bring it into 3ds Max. It's quite a simple part, it's not going to take very long to render up, but we're going to open it up and import it. We could again import it as native SolidWorks data should we want to. So if we want to come in and say, okay, well actually, apologies, actually we want to, I'm just going to put that on there and smile. Okay, so I'm not going to show you it in 3ds Max because it needs to install a plugin, which is really, really frustrating. Let me see if I can just open it natively from SolidWorks. Again, the plugins are out of the box, just a little bit frustrating more than anything else. Okay, we'll just do it a slightly different way for the purpose of this. Apologies, we've not done one of these for a little while, and therefore I need to do some updates, which is frustrating. So I'm just going to go out as a step for the purpose of this, just because I can, but rest assured it's not particularly what I wanted to do, but hey ho, it will give you us the ability to use the functionality. And I'm sure my team, which are probably watching right now, are going to have a good old giggle and wind me up about this shortly. So let's go and find the file. Step file we used. No, not open. Import, please. Thank you. And let's open the step file instead. We're just going to leave everything as default and just convert it to a 3ds Max mesh. And there is our geometry inside of Max. I'm not going to do any modeling or any hard selling on Max at this point. I'm just going to bring in the geometry and just place it here on my screen. You can see it does a pretty good job of the import. If it's an Inventor model directly, it will give you some better import options to handle large data nicer. But I'm going to come in and I'm going to assign a physical material to this. One material, so it's nice and easy. We're going to have a nice polished aluminium, and we're going to assign that to the component that I have selected, like so. Against the component, I'm going to tell it that it needs to treat it as a specific shape. For the purpose of this, I'm not getting into the exact uses of Max and how to use it. But we're going to convert and put a UVW map on here. This machine's acting very strange. UVW map, return. And again, we're going to say just treat it as a box. Although it's all bent and deformed, just treat it as a box for the purpose of this. I'm going to add a simple plane just to place below it, just so that we've got something to reflect some shadow. I'm going to throw on a plain material, it's maybe a matte paint finish, something that's maybe just off white down here, and I'm just going to throw that onto the floor. I'm not going to go in and put any lights on there at all. I'm just going to go in and do a quick setup. I'm going to tell it to render using Arnold. Arnold is a very high-end renderer for 3ds Max, and again, it comes out of the box. And I'm just going to hit render. I'm not doing anything other than telling it to go and hit render. And Max will go away, and it's a bit wishy-washy against the grey. It will go away and start producing a render. Bit noisy, but I haven't done any figuring out of this particular scene or lighting at this stage. Let's just come in and make this slightly grayer. Go and hit render again. And you can see that we start to get some nice handling of that material, nice crisp model. So if we just come in and start throwing in some lights, and I'm going to be really lazy and just put on the sun. So I'm going to go and say systems, go and use a daylight system, say yes, and just place a daylight system. We're going to imagine that this sheet metal component is sat out there in the sun. I'm going to just do a quick preview render and just make sure my exposure controls are about right. So let's come in and turn it on to automatic exposure control. And hit render again. Why are my renders not having any light? I'm having no luck today. This is fantastic for the first one back after X amount of weeks. Daylight system, there, up there somewhere in the sky, thank you. We have the sun and we have a component, brilliant. Let's place it around there, use default shading and render. I'm going to blame the PC. I'm going to blame the PC. Exposure control, nothing. 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 Good. The joys of live demonstrations. Sometimes I wish we'd pre-record these. Okay, let's just place a normal light on then. We'll give up with the sunlight in the daylight system. We'll do it the slightly longer way. New light. We're going to use an Arnold light. Place it on. Place it here. I'm just going to be lazy and place that just above the component, like so. Get a bit closer to it. And hit render. The exposure control is going to be all over the place now, so I better put it back on automatic. Let's just change it a little bit. Physical camera. No, we'll go back to linear. There we go. Hit render, and we'll start to get something that instantly looks a little bit more realistic because using a real live camera. You can imagine if you'd have gone through and spent a bit more time setting this up nicely with some lights, the softness of the shadows, even though this is on sort of draft quality, the softness of the shadows that you start to get instantly when you're adding decent lights on here really starts bringing this thing to life. You should check out our YouTube channel. I've got an Inventor to Max workflow where we create a studio ramp, put on a load of lights and make some photorealistic renders of Inventor bits and pieces. That's on our YouTube channel, so check that out. But yeah, I think that's probably it for today. Apologies for the mistakes. I guess there was a few bloopers in there, so my apologies. If there's anything you want to see in more detail next time around, just let me know. But the key, and going back to the original message, is whatever CAD data format you have, we can bring that data in and we can use it and edit it and add to it inside of Inventor. We can then sync it with Fusion 360 to start using some of that modern tools functionality that allows us to do more than you might be able to do inside of your existing subscription for one single price. And then should you want to render it, automate it with some code, again, it's all stuff that comes out of the box inside of Inventor and the Product Design Manufacturing Collection. So I hope that's been useful. Apologies for the bloopers and mistakes. We will be back next week, same time, 2 o'clock in the afternoon. And we will do another session similar to this. We're going to be focusing next week on AutoCAD to AEC collection. So transitioning from 2D to 3D using Revit and the different tools in the AEC collection. So I look forward to seeing you all then. I've got some updates to do on this machine. I'm going to hit it a few times with a hammer so we don't get the glitches. But thank you very much for your time. Thanks for joining us. Enjoy the sunshine today if it's sunny where you are. Enjoy your weekend, and I will catch you at the same time next week. Take care. Thank you very much. See you soon. Bye-bye.